so we can allow it to catch up.
Okay, so we go back to share more.
We're live now. Hi everyone. Hello everyone, this is Hania Ibrahim, a client developer advocate at IBM, and today's tech talk will be called an introduction to visual recognition. The speaker will be Rojan Jose, who is a fellow IBM client developer advocate. Just a couple of things to tell you before we get started with the talk. I'll be monitoring the chat for any questions, so if you're watching on the event page, go to the YouTube page and post any of the questions that you have here. And I'll be sure to answer them, or Rogan can answer it for you at the end of the talk. Also, if you didn't create already your IBM Cloud account, you can find a link to get your free IBM Cloud account in the description box below. So, without further ado, Rogan, let's get started.
Hello, Anya. Thank you for the introduction. So my name is Rojan Jose, and I'm a developer advocate at IBM, and I help developers build applications on IBM Cloud. So today's topic is Introduction to Visual Recognition, and we'll see how visual recognition service that comes with Watson service works and how you can use that and build your models. So here's a little look at the agenda. Start with a quick introduction to visual recognition, and then we will use what's known as the Visual Recognition Starter Kit to try out the Watson Visual Recognition service. After trying out, playing around with that a little, we will try to build a custom image classifier. We will train the service with some of the images that I've gathered and build a model around that. Once the model is ready and trained, we will try to access the model using an external application. And then finally, we try to deploy that application onto the cloud just to show an end-to-end scenario of how you would go about provisioning a service and end up using that service via an external application. And then finally, we'll wrap up our session. All right, so with that, let's get started. So what is computer vision? If you look at the picture on the left, as a human, I can instantly understand what that is. So I can see it's a vehicle with wheel shown there, and the tire is flat. Now, providing the computer the ability to see and understand the image is essentially what computer vision is. So essentially replicate the brain, the eyes, and the visual cortex function, and using camera, sensor, and AI algorithms like neural network. So some primary techniques that we apply for computer vision is image classification, object detection, image segmentation. So image classification helps us classify what's contained in an image. Image localization will specify the location of that subject in a given image. Object detection specifies the location of multiple images in a given image, multiple objects in a given image. And then finally, image segmentation that identify objects with proper boundaries. So for example, if you have a picture of a dog, or in this case a wheel, it can really identify the pixels that represent that object, and then you can mask that picture based on segmentation algorithms. The computer vision, the AI algorithms are very compute intensive, so it's very common to use hardware to accelerate the workload. So it's very common to use GPUs and FPGAs to run these types of training algorithms. And hardware is a continuing area to evolve, with a lot of companies investing in specialized hardware to train. On today's call, we will focus on image classification. We'll do a deeper dive and look at how Watson Services uses image classification. All right, so looking at some of the applications of computer vision, industrial applications. The most common that you must have heard and seen in everyday news is in automotive sector, which is self-driving cars. So starting to see a lot of cars coming out with driver assist technologies, and eventually hoping to see self-driving cars on the road. So that's purely computer vision application. On the energy and utility side, we have computer vision algorithms doing critical infrastructure monitoring. Rock analysis is an example where all companies are looking at rock to see the content of oil or it needs to be extracted for oil or not. On the agriculture side, we have farm management solutions available now which can monitor crop conditions, so you can fly drones over field, look at the field and analyze to see how your crops are doing, if the fertilizer is being applied effectively, if the irrigation system is optimized to reach all corners of your farm, of your field. There are applications for computer vision on livestock as well. So there are facial recognition applications that can, for example, monitor the cows in your farm and see if it's being fed properly by analyzing several parameters on the face of cow. On the retail side, store automation is getting traction. You must have heard about the Amazon Go. Theft reduction is another area where surveillance cameras are capturing shoplifting and trying to avoid that. On healthcare, analyzing X-rays, mammograms, and other types of scans to diagnose diseases. These algorithms are working and helping our doctors assist diagnose disease more effectively. It's also being applied on operation theaters when surgery is happening to monitor blood level during surgical procedures. And then in general, face recognition is face recognition based algorithms are being used heavily in security and surveillance applications. Video searches is common in media industry to sift through volumes of videos and understand the content and look for certain subjects. All right, so that was a quick introduction to visual recognition, and then let's look at what Watson offers in the area of visual recognition. So Watson Visual Recognition is an image recognition service.
Sorry to interrupt you, Rojan, but can you raise your voice a bit?
Yeah, okay. Is this better? Yeah?
Yeah, I think so.
Okay. So, yeah, the image recognition service enables user to quickly and accurately tag and classify visual content using machine learning techniques. The visual recognition service comes with a set of pre-trained models, and it also allows you an option to create your own model. So you can create your custom model. The great thing about the service is that anybody can start. You don't need to know the lower level workings of how AI algorithms work. So you don't need much of coding skill to just use this service. You don't need the data science skills like neural networks to build a model, to build the algorithm behind the model. It just gives you an interface to create a model, and you can quickly upload your data. All you need is you need to come with your data and upload the data, and you have your model up and running in a matter of hours, depending on how much data you have and how much training is required to build your model. The visual recognition service also offers you SDKs to access these trained models via your application. So it has support for several languages like Node.js, .NET, Java, etc. Here's a list of models that we have in the visual recognition service. So the three on the top are pre-built models. General model is basically an image classification model, and it has thousands of classes pre-built into it. And these classes have categories and subcategories arranged in a hierarchy with categories and subcategories. And for each category, it throws out the results with a confidence score. A confidence score that varies from 0 to 1, anywhere in between. We also have a model called food. This service is to recognize the food or the meal that you want to classify. And then the third one is explicit. So if you have images containing inappropriate content and you want to check whether it's suitable for certain audience or not, you can use the service to do that classification. And then we have two other models where you can build custom. Two other ways to build custom models. So first is called the custom classifier, where Watson will train and understand your custom content. You can upload your images and create your own model to classify the set of images that you have to solve your problem. We also have an object detection service. You can again upload your images and try to detect different objects within your model. All right, so looking deeper into general model, as I mentioned, it has got thousands of classes built into it. So classes like animals, person, food, plants, sports, etc. And these classes have hierarchical reasoning built into it, and it can boost the confidence of parent categories depending on the image that you feed. So if you look at this example, for instance, you're supplying a image of a Chihuahua. So the model recognizes that it's a Chihuahua, and then assigns it a score of 0.97. It also understands that it's a dog, an animal, and which are the parent categories. And based on that, it raises the score for that, and the score goes up to 0.98. So that's what I meant by boosting the parent category. So how does your custom model work? You can create your custom models using your own data. So there are two ways to do it. You can choose to have a simple classifier, binary classifier with single class. You create a class and feed the model with your test images. You also feed with some negative examples to show what to reject. Or you can have multi-class classifier where you can have class of similar objects defined into subclasses. So if you look at the example on the right, let's say you want to build a model that can identify fruits. You feed the model with apples, bananas, and pears. Gets classified as fruits, and then feed some negative example, vegetable and cheese, so that model can reject those images. And then you train the model. And then further, if you want to enhance your model, you can come back and edit the model and retrain. Let's say you want to add oranges to it. So you feed a set of oranges as an example and create a new class based on orange. The model should be able to recognize oranges as well. So in terms of recommendation, the number of images can vary depending on what you're trying to train. So recommended size is to have up to 200, from 200 to 500 images, and you get a model with less inner class variability. And then if you want to have a final model, that you go up to 15,000 images to train them on. Which should include per class. Yeah, I just want to mention this is per class, which should include negative images as well. Some of the requirements for this service, you need to have images that are in JPEG or PNG format. So there are two calls, training calls and classify calls. So for training calls, there are limitations on the size of the data that you're providing. So if you're using zip files, you can have a maximum of 100 MB per zip file for training call with 10,000 images, minimum of 10 images. If you're just sending an image, the image cannot be larger than 256 MB. For classify calls, the maximum image size for a zip file should not be larger than 10 MB. And for an image, 100 MB. There are some additional guidelines on what the good training techniques are and what you should do if you're doing a high volume classification. And I'm not going to list all that out here. It's all documented well, so say refer to the documentation when you're trying to build a production model with large volume of data. All right, so that was a quick introduction to the Watson Visual Recognition service. What I'm going to do next is show you how to provision the service on IBM Cloud. And for that, I'm going to use a new ID. I'll walk you through the steps to provision, starting from creating a cloud account. I've created a new ID, so you will see how, if you're starting new, you will see how to go ahead and create your IBM account and then provision your service. So first thing I do is go to IBM.com. Let me log out of this. I'll use my new ID. And then click on Create IBM Account. And use my new ID that I created for this demo. So if you were to have an account here, it will automatically recognize this ID and ask you to log in instead of creating a new account. So create account. So as next step, it says that a registration email was sent to my email ID, so check for that and confirm. Oh, hold on, not this one. So let me open that in a different browser. And here, let's use this. Okay. So that's the email confirmation. Confirm the account. All right, all done. So I'll go back to new ID. Confirm. What's going on? Alright, so I'm trying it in a different browser, and this is the next one I get. Proceed. And what you see here is the dashboard. You see resource summary and a few other details, location status, etc., etc. And on the left side, you have the menu to see different options. So I want to see all the resources that are assigned to my account. So right now it's all at 0 because it's a brand new account and I don't have anything provisioned yet. So that's how you create a new IBM Cloud account. Now let's get into provisioning the Watson service. So for that, you click on Catalog and then go to the AI service from the catalog. So you filter out by AI. And if you scroll down, you should see Watson Visual Recognition. Click on that, and it gives you a light plan that any user trying out Watson for the first time can use, create. There are some prereqs that's required. So for example, you need a Watson Studio service setup and things like that. But as I mentioned in the agenda, that we are going to try something different. We're going to try the starter kit, which not only gives you the visual recognition service, but also gives you a prepackaged application, a Node.js application, and installing all the prerequisites so that we can try this thing end to end. So instead of creating Watson Visual Recognition service, I'll go and start with the starter kit. So I go back to catalog and click on starter kit and scroll down to the bottom, and you will see the starter kit called Watson Visual Recognition Basic. So as you can see here, the starter kit comes with a Node.js application. You can deploy something that you can deploy into IBM Cloud. It will connect to, it will also provision a visual recognition service and connect to the visual recognition service. And then, the application will access the models from that visual recognition service. So this is what we want to use today. Click on Create App. Rename this to Demo. And I want to select the region as Dallas. And click on Create. Okay. So what happens here is it's installing an app called Visual Recognition Basic Demo Starter Kit app, and inside the app you can see that visual recognition service has been provisioned. There are some links to resources here, so if you want to look at the documentation, it tells you how to start using a visual recognition service with demo and some instructions to create your own model. Also provides you the links to the API reference. So it shows you what are the different methods here and how to invoke those, right? How would you use it in a .NET program, or how would you use it in a Java or list of languages that's available there. All right, so let's dive into the tool. Try that again. All right, let's see, is it not provisioned yet? So let's see what are the services that are provisioned so far. How do I do that? I go back to the resource list. Okay, so I do see Watson Visual Recognition service provision. Try to access it again. All right. So what you would see next is try this again. Go back to my app, the starter kit app. Okay. Well, I think I'll have to. I'm not sure what's going on with the service right now. Let me try from another account then. Okay. So here's my other account, and I'm going to try this again. So I go back to my catalog. So starter kit, visual recognition basic, and create the app. All right. Okay, so that seems to work. So I don't know what happened to my demo account. So what I would do there is go back, delete it, and try again. So let's proceed here. So I created my starter kit. If I go back to my resource list, see a bunch of service. This is the starter kit app, and I have a bunch of other services here. These were provisioned earlier, but this one that you see here is Watson Recognition service that was provisioned by the starter kit. All right, so I'm in the service now, Watson Studio. And if you don't know what's the studio is, it's basically a tool that provides you all the necessary tools and a collaborative environment to work on your AI projects. So as I mentioned earlier, there are 3 pre-built models. Let's test out some of these, right? So I'm going to test out a general model first. So I open the model, click on the test tab, and feed it with some data. Let's say I want to test this image. It's even I can tell it's sushi. So when I fed it to the general model, look at the results. So it identifies that it's a sushi roll, plate of sushi roll with 0.99 confidence score. It's a dish, it's food, nutrition, etc., etc. It identifies some of the colors as well. So that's how general model works. But let's see what happens if I go back and try this same image with the food model. All right, so here it is more confident that it's food. It tells exactly that it's a California roll and it's a sushi. So you notice the difference between the results coming out of a general model and a food model, and kind of explains why you want to build your custom model when you're looking at a problem area where you want to narrow down the scope to a certain set of images, certain subjects, then you use a custom model to build that, and that's what we will do today. Before I do that, let's look at what we want to do for our use case, right? What kind of images that we want to narrow it down to. So going back to my use case here. All right, so I was looking at this app called Nextdoor the other day, and it's a neighborhood app where there are communities participating, exchanging questions, and question answers, and helping neighbors, helping each other. So I saw this post which said, "Look what I found. Anyone knows what the snake is?" And that rang a bell because I spotted snake in my yard as well a few months ago, and I couldn't figure out what kind of snake that was. So I said, okay, why not try this out in the model and see what the results are. So as you see in this post, people are trying to identify. Somebody says it's a copperhead, others are not sure. So it's obviously a problem, and yeah, it's hard to look at snakes. I'm scared of snakes, but I said, why not? Why not give it a try and see what happens? So I did some research, went to this website to see what are the different types of snakes. So it happened. I live in North Carolina, and in North Carolina there are about 37 species of snakes, out of which only 6 are poisonous. And then I think where it gets complex is where some of the poisonous and non-poisonous look alike, makes it hard to identify because the patterns are similar, and on a fast-moving snake, it's hard to tell whether it's a venomous snake or not. If you look at the last one, so I've listed 5 out of 6 venomous snakes here. I think the 6th one is another type of rattlesnake. If you look at the last one here, eastern coral, it's a very poisonous snake, and on the right side, you see a scarlet king snake, which is a lookalike, which is non-venomous. There are lesser features to differentiate these images, so I would think that, even for a CV algorithm, a computer vision algorithm, it would be hard to differentiate. I wanted to try out what the score would be. So I went to this site, so let's go to the site. Just before I go to the site, on the right side, you see there are some lizards that are found here, salamanders, which can be confusing as well. If you look from a distance, they don't have toes, so they can look like snakes. So let me go to the site to show what some of the images look like. So these are 37 different snakes species from North Carolina. And if I were to look at copperhead, there are some images at the bottom here. So when you train model, you need a set of images to train, and then you want to keep a set of images to test. So I decided to use this as test image, and went to internet, gathered some images on these snakes. I searched by the name, the common name and the scientific name, gather some of the images, and collected my data set. This is what I got, and put them in a folder. So my idea is to create classes for each of these snakes so that it can identify snakes found in North Carolina more accurately. So within each of these snake folders, I gathered about 10 to 20 images. So minimum set of images per recommendation is 10. So I gathered at least 10, in some cases 20 to 30 images, and then created zip files out of them. I also used the same set of images to create venomous and non-venomous snake. And then zip them up as venomous and non-venomous snake. All right, so that's the set of data. So let's go ahead and try to build a custom model using this data. All right, so for that, I go back to my model. And click on this project called Create Custom Model. So when you start in Watson Studio, you want to start with the project, and your models will get created under the project. So let me call the project VR Demo. All right, I can create a new class by clicking on this plus icon and give a name to the class. And then it says to add 10 images. So what I can do is browse. So if I go into this class, I can click on drop a zip file and then drag and drop the zip file here. There's an easier way to do it, and that's what I'm going to use it. So if I bring the zip files into this project, it will automatically create the classes for me. So let's do that. So I go into my zip folder. And let me create a few first. So as I'm selecting zip file, you can see it's automatically uploading the zip file and bring that into model, and with the class name, so the name of the zip file or the folder name inside the zip file becomes the name of the class. Alright, so if I were to look at this class, you can see all the images that you gathered are classified under this class, Copperhead. Okay, so once you have model, so yeah, that's the other way to go back to your model. You come to your asset folder from the project, and the model is at the bottom. Click on that. I want to give it a proper name as well, so let me call it North Carolina. So NC Snake identification model. Then once you have the necessary images uploaded, okay. So there's one class which needs at least 10 images. So I'm going to delete it because I'm not going to use this one. All right. So I think we're ready to train the model. Once you have all the images uploaded, just click on train model, and it starts the training process. So the training process can take somewhere between 10 to 15 minutes or even more, depending on how many images you're trying to train. So I don't know if you want to wait. So let's not wait till training is over. So what I've done is I've run this already in my another project. So I'm going to pull that up and we'll continue with the train model. So let me make that go up. All right, I'm going to log in as another one, another user where I have the train model ready. Okay. So okay. So see here, I have this visual recognition service which is already provisioned, and I have two train models. One is called the snake identification model, and the other one is the toxicity model. So I created two models, one for identification, one to determine whether a snake is venomous or not. Let's look at. As you can see, I pretty much imported all the data that I collected, and I've trained it. You can see the log that already says that this is already trained, cannot be deleted. So let's go ahead and test the model now. Well, before I test my model, I wanted to show you what the test result would look like if I were to use a generic model and apply my use case there, right? So All right. So if I were to try the copperhead now on my tested model, you can see the result is showing with a much higher confidence that it is a copperhead. And the other classes has got a 0 score. Ignore the zip. I think classes have zip in it because initially when I trained this model, I had not zipped the file properly. So you need to zip the folder with your images instead of just selecting the images and zipping it. Let's try another few others. See what the results look like. So as you can see, the uploaded images are being classified correctly. So this is a cottonmouth. These two are cottonmouth. Low score for rat snake. This one has a higher score for eastern diamondback, probably because of the patterns on its back. Has some similarity to eastern diamondback. This is getting identified correctly as eastern coral snake. This one has eastern diamondback, and this one is being identified correctly as. Oh well, this one was a. Okay, this one is not getting identified correctly. Eastern rupin, eastern grass lizard. Okay, and that may be because I have not fed the model with negative examples yet. So what I've done is I've created the zip file with the grass lizard and the salamanders, but I've not trained the model yet with the negative example. Once I train that, I'm sure this score will go down. Okay. All right. So we have a trained model. What does it look on the toxicity side? So another model with toxicity with two classes, venomous and non-venomous. And if I will test that, let's say try copperhead. So I try a bunch of these. So copperhead is being identified as venomous. This one, I guess, it's confused because it has got an image of coral as well as the scarlet look-alike. So it's a scarlet corn snake is venomous, but the other one is not. So there are multiple objects here. Maybe that's causing confusion. Corn snake is correctly being identified as non-venomous, whereas cottonmouth is shown as non-venomous as well. So that's not correct. Maybe I need to train this model with more data on for cottonmouth. I need to go back and check if I've put sufficient data for cottonmouth as venomous or not. But I checked a few other, and for most of the other snakes, it showed the categories correctly. All right. So why did I choose to build two models? Because I want to have more accurate results. So instead of creating one model with all the classes within it, what tends to happen is it reduces the score on identification. It mixes up and reduces the score on identification in venomous classes. It brings down the confidence score considerably. With this approach, I was able to get a higher confidence score with less amount of data. So maybe when I'm building single model with different types of classes, I need to feed it with more data. All right, so our models are ready. I think what our next step is, we want to invoke this from an application, right? So for that, we'll go back to our starter kit use the application that came along with it and try to see if we can run that model, run these models from the application, or rather access the models from the application. So to do that, I'm going to go back to my previous account where I had the starter kit created. So I go back to my starter kit. This one. And click on download the code. So what's happening here, it's generating all the necessary code, packaging it as a zip file, and doing that. Alright, so I have the zip file. Okay, so let me bring that into my demo folder. Okay, so I have the project now in my demo folder. So let's take a look at that. And that's the folder. You to that folder. And let's take a look at the code. Opening the project in Visual Code. And as you can see, it's a Node.js application. We start with the README file. Okay, there's a few. All right. So just like any other Node.js application, if you want to try it, you just run the command locally called npm install and then npm start to run the application. You can access the application via this URL. Today we want to try deploying this application into the cloud. So we're going to follow the steps, but before that, I also wanted to try deploying it locally and testing it locally using the IBM CLI tools. So we'll walk through those steps, use the IBM Cloud to build and dev and run this application locally before we deploy it as a Cloud Foundry application. So if you look at the directory structure here, looks like a typical Node.js application. It's running express.js middleware, and it has React components for the UI part. All right, so let's run this as is and see what happens. So first command is run rm minus rf node modules. So since this has not been built yet, even once, I don't see node modules. I don't think we need to run that command. IBM Cloud build. So that's the command to run the build. And this will take a few minutes to run. While it's running, let's take a look at what are the prerequisites to run this command. So we need to install IBM Cloud tools. And if I click on that link, it tells me that you need to install CLI. When you install CLI, it will install a bunch of plugins for you and a set of commands to install it. Use the command called IBM Cloud login to your cloud account. You set your target, Cloud Foundry, which is what we will do today. So it's simple simple instruction where you just run this curl command and you have your install IBM Cloud CLI ready. All right. So let's go back, see how the build is going. And once the build is complete, to run it, just run the command called IBM Cloud dev run. Alright, so it's still installing. Just give it a minute or so. While we're waiting for the build to complete, I just wanted to show you guys real quick the learning path from our developer.ibm.com website. Here's the link. Anya is going to post this link in the video description later, but if you're getting started with visual recognition, go to this learning path, and it has got a series of articles, code patterns, tutorials that you can follow along and get started with computer vision. There are some cool applications as part of code pattern that you can do. So this one, for example, is an iOS application to build custom classifier. So click on that link, and you would see a link to the GitHub. If you go there, you can get hold of the code to build this iOS application. And what it does is it shows you how to build a custom classifier. And the example they picked is the cables, the HDMI, different types of cables, identifying what the cables are. Run it as an iOS application. There's another one which is interesting as well. This code pattern here helps you identify vehicle damages. So this one is a web application as well, but it's built using Cordova. And it gives you step-by-step instruction to build your application. All right. Let's go back. Build. Now, one of the prerequisites for you to run this is Docker, and I do have Docker. My engine is 19.0.3. Looks like the build is complete. So now let's do the run. IBM Cloud dev run. It's taking. All right. Okay, starting between our. Okay, the application is now running, so let's test it out. Localhost 3000. So this is the demo application that comes with the starter kit. And you can see this landing page provides you a set of images. And if you select one, it applies the general classifier, and it figures out that it's a platform machine, jet engine, and several other classes associated with it. All right, this one. Okay. Now, what happens if I try the image that I was talking about earlier, like my use case, identifying the snake? So if I were to select my image, this one. So interestingly, it did not, so the general classifier did not pick up anything that says it's snake. It's actually not able to find a snake in this picture. And that's understandable because of the picture, right? It's a long shot, and snake, you can barely see snake. So when you collect data for your model, you need to make sure that subject has sufficient details. It's zoomed in, and there's sufficient details to for model to work through it, right? So that's probably why it doesn't show any class related to snake. What I did instead is I zoomed in. I a zoomed in picture of the same image. So if I were to try with that, in this case, it at least it figures out there is a snake, and it's an uptile. So this is much better result than the previous image that I got from next door. It's giving me a few classes for snakes as well, but none of the snakes are found in North Carolina, so these results are not correct. We will try to feed this same image through our application now and see what the result is. So we will try running the same image with the custom classifier that I built earlier, and let's say we want to try this from this web app. So what are the changes that I need? We're going to make some quick changes to the web app and deploy it again to see if we can invoke the model from this web app. So what I'm going to do for that is open the Visual Code Editor, go back to the source. There are a couple of changes that I need to make. So if I go look at this is the first file where it gets all the credentials. So I want to replace the credentials with the service that I created with my trained model, right? So let me do that first. So for that, I need to go and find my service where I have the trained model. Okay, and so I'll open the service and go to service credentials. And copy it, bring it to Visual Code. Paste it here. The variable names are different. I want to make the variable names same so that create the application doesn't have to be complete file. Yeah, so the application just prefixes Watson with the variable name. Here I have the credential set, save this file. So that's one change I need to make. What are the other changes that I need to make? So if I go to the routes and look at different routes defined here, it's the main that I need to look at. And let me go and find the classified ID. So if you look at this code here,
Rogan, I think you missed the CRN.
Default and food.
Sorry to interrupt you. I think you missed changing the CRN as well.
Sorry, what was that?
I think you missed changing the local dev .com file. I think you missed changing the IM service ID CRN. Yeah.
IM role.
The one before the last. Yeah.
Oh yeah. Go back. Okay. Let's try that again. So good. Thank you for
You're welcome.
seeing that and letting me know. Okay, so API key. File replace API key. IM role. Service ID. And URL. Does that look better?
Yeah, we're good to go.
Hold on. Am I looking at the right service though? Because the values look same to me, so maybe. not looking at the right surface. Let me go back and
yeah, I think they're the same.
Since I had to switch between too many accounts
Yeah.
here, I am, okay, this is the one that I want to use. Visual recognition. Yeah, this is the one where I have the trained model. Oh, so it is using the right. Okay, then I think I can leave this as is. It should work. Okay, and then going back to the main. So the main, so these are, so it's basically using two classifiers here to classify your image. So what it does is it iterates through both the classifier and gives you the result. What we saw earlier in my test for the snake image, it was only showing one because I think the results were coming out empty for food, which made sense. So in my example, as I was showing, we have two classifiers. So let's replace these classifiers with the new classifier that I created, right? So for that, I'm going to go back to my Watson Studio and grab the classifier ID. So this is classifier ID for the snake model, snake identification model. Then I'm also going to go get the ID for the toxicity model. Okay, so that's the other change I want to make. What else? Let's say I want to replace some of those images, right? With my test images, I can do that as well. So let me go grab that. Where do those get picked from? So it's in the view. And Livestock.jsx uses demo. And so here's the code for that. So the picture that are shown in the landing page is getting picked up from here. Sample images 1, 2, 3, 4. Let's say I want to replace these images with mine. So I go to my test images and I've already created some that I want to copy into my application now. That's under public images. I'm going to paste it here. All right, and then my images are PNG, so I want to replace PNG. Okay, so I think I have made the necessary changes to look through my service, invoke my classification model, and replacing the identifiers, and then puts my sample images. So let's try rebuild this and see what happens. So I get out of it, use it again. So while it's building, let's take another look at what the code is doing here, right? So this is the main code where the bulk of the work happens. So this method here called classify is basically what gets invoked from the UI side. As I mentioned earlier, it's looking at these two classifier models now, and these lines of code are to look at the parameter to see what's coming in. If it's an image that's being selected from the landing page, then it uses that. Otherwise, it parses. If you're uploading an image, it parses that image and stores it as a file for later use. So then, depending on the parameters that you pass in, this is really the API Node.js SDK that's getting invoked. to run the classification. So visual recognition method is classifier, and then you're passing the parameters. And then it asynchronously runs this across the different classifier IDs that you have provided and sends the result back for rendering. So, okay, so the build is done here. Let me run it again. Okay. All right, the app is up and running, so let's test this out. There you go. So you see the changes here. All my images are shown, and let's say I select the first one, and as you can see, it's correctly getting identified as corn snake, and it's non-venomous. Let's try another one. This is a copperhead, and it is venomous. So this is fairly good results as far as I can see. Oh, well, this one maybe not. That's not a diamondback. Is it a diamondback? Oh, maybe it is. I'm getting confused here. I know this one. This is a pygmy rattlesnake. Yeah. It is pygmy rattlesnake, and it's not. Oh, it is venomous, so this is not getting classified. I need to go back and check my data and see if I'm feeding enough data. I'm thinking that's what's causing this problem, but it is a pygmy rattlesnake, and it is venomous. So let's see what happens to the image that I found from next door. So if I were to load the zoomed in image, oh wow, interesting. So the folks at Nextdoor identified as copperhead. Watson is saying, no, this is, my model says it's Eastern Diamondback with a score of 0.56. It could be a cottonmouth. It's definitely not cottonmouth. It might be Diamondback. I don't know. But it's interesting to see that based on the training, it does not identify it as copperhead. And it says it is venomous, so that's accurate as well. All right, so that was the application running locally. So one last step that I want to do today is to run this as a Cloud Foundry app on IBM Cloud. So how do we do that? I quit out of it, and let's follow the instructions to deploy this as a Cloud Foundry app. So I scroll up, and first thing I need to do is log in. I'm logging into my web computer. So one, it's just my personal space. is set targets. Okay, so it's important that your Oregon space is set. If you're having difficulty, you need to make sure that your region is set to US South, because I believe that's where Cloud Foundry infrastructure is available as of now. So if you're having trouble setting these, make sure your region is set correctly before you run the target. Once the target is set, the next thing is do it deploy. So I can cloud dev deploy. Go into my resources, refresh, and expecting it to show up here in my list of Cloud Foundry apps. Oh, this is already deployed. Let's see. So I'm mixing up my account again. App. Let me see if I can deploy this into the new ID that I created. So we'll try this again. Login. Oh, enter the host name for. Okay, well, let's try that. Sorry. Okay. All right. So Oregon space is set. Let me deploy again. Okay. Validating the host name. Oh, the name is taken. I see. I should have given another name for demo. All right, so I think what I'll have to do is go and remove the application from one of the places where it's running.
ايوه سوري انا اصل انا بوست الويبينار دلوقتي فكان هيرن على اللابتوب فقفلت. ولا يهمك. اوكي. بوجاناركا بتقول لي ان هو ميرنا ما بعتليش حاجه. بتقولي النيو نمبر ما تبعتليش. بصي هو انا اتكلمت مع الكيترينج وهو هيجيب الحاجه.
Well, honey, I think we are almost out of time, and I think
قال لي طب البي او ما البي او
what I need to do here is that the application is running from my previous deploy somewhere, so that host name is taken. So what we need to do is either we'll change the manifest file to update the new host name, or the application from the other cloud account where it's running and try to deploy it again. So instead of me trying to
بصي
figure all
هو
that
كان
out.
هو
I
كلمني
think I
قبل
just
ما
showed
هو
how
قلت
to
لي
deploy it.
but it's not شهيد.
Once you run this command,
طب ممكن تبعتي ايميل تاني بمجرد
the application gets deployed as a Cloud Foundry application into the IBM Cloud account, and then you get the URL. Let me see if I can find the deployed app so that I'll show you the end result.
ايه؟ انتي مش عارفة تعمليه؟ يعني انسانية واحدة دلوقتي تقدري اكسبت وبعد كده هتدخلي بجداركا ولا العكس؟ ايوه طيب يعني تبعتلها تاني بتقولي الرقم ما جالهاش التيكت ما جاتلهاش اللي انتي عملتيها قالت لي التيكت اللي انتي عملتيها ما جاتلهاش انا مش عارفه هي ليه بتقولي انا ما بتقوليش انت بصراحه مش عارفه طيب حاضر بصي هو انا هخلص كمان ساعه
Okay,
فعشان
so
كده
I think we'll have to end it here.
طيب
But yeah, that was my demo for today. And then I have a few
عشان انا دلوقتي هعمل
links
يعني
here.
هتكلم كمان دقيقه تقريبا
Basically points to several other resources that you can follow along. So before we close, I want to hand it back to Hanya because she wanted to make a few more announcements regarding the next webcast. Are there any questions in the chat?
Yeah, so Carlos asked what is the minimum amount of images to test a model?
The minimum, that's 10. So per class you need to set 10 images, upload 10 images, and model will let you train.
Okay, so 10 images for every class or for the model?
For every class,
okay.
yeah.
Okay, so and
That's
someone
fine.
else asked, how many images do you have in your training set?
In my training set, I have about, so for each class, I've created like 16, or sorry, not 16, about 10 classes, and within each class, I have, depending on class, a minimum of 10 all the way to 30 images.
Okay. I'm not seeing any other questions.
So let me
Guys, do you have any other questions before we sign off? Just post them in the live chat.
Okay.
While you do that, guys, make sure to check out next week's NLP introduction talk. We're going to have it at the same time. And we're actually running a digital developer conference. We had 2 other dates that ran earlier this month. The next date will be tomorrow. It'll be 12 p.m. European time. So if you go to developer.ibm.com and write digital developer conference, you'll find all the information you have. And there's another date as well on the 23rd of November. That is at 12 p.m. Tokyo time. So if you want, you can go check it out. There's 2 tracks, one for cloud native, one for machine learning. I think it's very interesting, and if you guys want to learn more about these tracks, please go check it out. And if you want to watch any other tech talks, you can find the tech talks in our YouTube page in the IBM Developer Tech Talks playlist. And if you have any like ideas on what you want to watch next for tech talks, please make sure to leave a comment below with like the area of technology that you would like to see a tech talk centered on. So thanks guys for watching, and we'll see you next Wednesday.
Thank you.